Deep learning has gotten a massive amount of press coverage over the past few years, and for good reason. Deep learning has achieved striking breakthroughs in problems that have been, historically, difficult for traditional machine learning. The current boom in deep learning interest can be traced to 2012, when the algorithm was applied to the ImageNet dataset consisting of 1,000 different categories and 1.4 million images. Handwriting transcription is another example, and we'll implement solutions for both throughout this course. Another high-profile use of deep learning is in the algorithm that powers the current explosion of interest in autonomous driving. Following this initial breakthrough, we've now seen deep learning successfully applied to speech recognition, automatic translation, and natural language processing. We'll also take a look at this example in the second half of the video course. One of the biggest breakthroughs came when deep learning algorithms beat the world's best Go player, and that algorithm has been improving ever since. Deep learning has practical applications in our daily lives, such as predicting customer behavior, like in this example from Zalando, a large online retail store. And if you're using an iPhone X, the face recognition algorithm is based on a deep learning neural network, just as activating Apple's digital assistant Siri is. In the coming years, there will be many attempts to apply deep learning to an even wider array of problems. Basically, anywhere where we're trying to predict something based on a large data set will be fair game. Medical imaging is often cited as ripe for a deep learning revolution. Even if the percentage of successful applications are in the single digits, the potential of deep learning is still enormous. And that's why Manning Publishers has put together this video course. If you're already familiar with R and want to understand and see practical implementations of deep learning, then this is the course for you. My name is Rick Scavetta, and I'd like to give you a short introduction to the course's objectives and prerequisites. This video course complements the Deep Learning with R book, but it's not just an audiovisual version of the book's contents. I've left out some material that may be unnecessary or too detailed for a video course. I retained the core lessons from the book and arranged them in an order to make learning a little bit easier in this medium. I've also rounded out the material with plenty of examples and descriptions that are not found in the book. In the end, this video course is very much based on the book, and although you can use it to help you study the book, it is a standalone course. As with the book, I don't assume any prior knowledge of deep learning. That's what we're here to learn. I do, however, assume some background in R. If you don't have a lot of experience, don't worry. You'll still be able to run the examples, but you will encounter difficulties when you start to work with your own data after the course. Also, I'll expect that you know common data munging functions and concepts in R. We'll be using Amazon Web Services and a small amount of shell commands, so if you have basic knowledge here, it will come in handy. But I'll walk you through the process from the very beginning. Similar to the book, I don't assume any background in statistics or machine learning. But if you do have some background in this area, it will help you put things into context. I'll try and fill in the gaps as we go along. Although there is some math in the book, it's pretty much the minimum amount you need to understand and implement a deep learning model. Our goal is to help you develop an intuitive feeling for deep learning, so we're not expecting mathematicians, but I do feel that some math knowledge is inevitable. By the end of the course, you should be comfortable reading and understanding equations like this one. If you feel put off by looking at equations like this, don't worry. I guarantee you'll understand this even with a basic maths background. So you don't need that much background knowledge to benefit from this course and learn deep learning. But there is one thing that I think is pretty important: your practical experience working with different data sources and analytical problems. If you're already working with large amounts of data, deep learning will present you with a new and completely different way of understanding your data from the techniques you've probably been using so far. Perhaps you're a statistician or a data scientist and you're already familiar with R but want to round out your skill set with deep learning. If you don't have much experience so far, this course will serve as a gentle introduction to some classic analytical problems, except that we'll be using deep learning to address them. By the end of this course, I want you to be able to develop and implement deep learning algorithms on your own. To that end, I have 3 goals. First, you'll have a good overview of the most frequently used neural network architectures, and you'll understand why and when they're used. Second, you'll become familiar with all the parameters and hyperparameters used in those networks, and you'll understand how they influence the success of your models. And finally, you'll have a practical command of the functions in the keras package in R, and you'll understand how they're used in concert to build deep learning models. This package provides access to underlying frameworks for implementing deep learning. Although there are several ways to do this in R, for us, deep learning in R is always going to refer to the keras package. Why is keras so important? Well, as data and hardware have become more accessible, so too has the software that powers deep learning. Once the domain of specialists, deep learning is now a tool for all data scientists. Keras had a large role in the simplification by making complex underlying functions easily accessible. The good news is that if you're working natively in R, you can continue doing so. The Deep Learning with R book was written by two prominent programmers in the field. François Chollet is currently working on deep learning at Google and is the creator of keras in Python. He is also the author of the original Deep Learning with Python book. JJ Allaire is the founder and CEO of RStudio and the developer of the R interface to keras. He adapted François' book for R users. My name is Scavetta, and I've written and produced this video and exercise series. I'm a biologist by training, but over the past 6 years I've focused on data science and have trained young scientists from a variety of disciplines online and in small group workshops on how to understand and communicate their data. You may have seen my courses on data visualization with ggplot2 at datacamp.com. I'm going to expand on the content of the book, showing how it relates to the wider data science field, but also to real-world situations. I'll try to make abstract concepts clear by using intuitive analogies and exploring examples from the book in more detail. We'll solve some of the exercises in the book, and I'll discuss their take-home messages in detail. I'm also going to tie all this new material together with a deep learning roadmap that I'll refer to throughout the series. I'll also walk you through all the coding examples in the book, pointing out interesting features, testing a function's other arguments, and looking at object structures. In addition, I'll periodically test your knowledge with a set of exercises. My hope is that this series will provide a more stimulating learning experience, and that's really the point. The more ways we can stimulate our brains as we learn, the better we retain that information, in particular with something as complex as deep learning. I'm excited to introduce you to this new resource from Manning Publications, so let's get started.